that up with Jeff Lampy. Today is a very special honor for me because I get to introduce you guys to two of my most favorite subjects. First one is electricity. See that? Okay. Second, electricity. Second is Nikola Tesla. Can anybody tell me who he is?
He's the one who invented that.
He's the father of AC current. He's the guy, he's the man that developed the generator, or the transformers, the generators, the alternators, and the motors that we still use today. He designed those way back in the late 1800s, over 100 years ago, and we're still using his design today because we can't come up with anything any better. So, in fact, because of that, he's considered to be the genius that lit the world. Which, yeah, the genius that lit the world. Now, Tesla lit over 2 miles of lights on his property without wires for the president of Edison Electric Company back in 1894. Now, president of Edison Electric Company was rather impressed by it. He asked him, he said, so where do I put the meter? In other words, if they couldn't make money off of it, they didn't want nothing to do with it. So Tesla, that kind of bothered him, but he moved on because he's a great scientist. Today, world-renowned scientists refer to him as the smartest man that ever lived. Smarter than Albert Einstein did. See, we'll get to a couple of points on that, but one of them, Einstein's time-space continuum theory. You guys ever heard of that? It's transporting something from one point to another without anything but, science. No motors, no nothing, and it instantly transfers it. Well, that theory of his is based, one of the things he based it on was Tesla's high-frequency rotating electromagnetic field. Okay. Let me give you a little Tesla fact and a little Tesla legend here. Nikola Tesla, okay, on July 10th, 1856, in the small town, or small village of Smilogen, which is kind of hard to, I may not even be saying it right, but it looks like I'm saying it right. The reason being is that was way back in the 1800s is what it was called. So they don't call it that anymore, and those old world names are kind of hard to pronounce. So please excuse me if I'm wrong. But anyhow, there was a severe thunderstorm on that day, and it was during that thunderstorm that Tesla was born, which is kind of fitting because later he was referred to as having electricity in his veins instead of blood, which is kind of neat, but it's untrue though, But anyhow, the legend is that lightning struck so close to his house that it caused his mother to go into premature labor, and that's why he was born during the storm. Now, there's nothing to back that up. That's why it's just legend. So, anyhow, let me stop and explain a little bit of how this works at this point. Okay. You guys talked a little bit about molecules, right? Talked a little bit about atoms. Well, everything, I'm going to go into it a little deeper for you. Everything that exists in our realm of reality has to be made up of molecules, and it has to have a molecular harmonics. This wood is made out of molecules. We're made out of molecules. In fact, because we have molecules, hoping you guys can see this. Turn this on a notch. Is it on? Yeah. Okay. And I'm reading current, right? There's voltage there. It's my molecular harmonics that thing's picking up. It's reading it. It's reading the energy that's within me. There's no battery in any of this, is there? So we don't get recharged at night. We don't, none of that happens. So where do we get the energy, the electricity that pulses between our particles? We get that from our molecular harmonics. Now, Tesla kind of understood all that, okay? And which is really amazing, all right? But anyhow, when the molecules get, they have a certain harmonics that they put out a normal rate. When they're out of their normal rate of harmonics, they start to emit a greater energy, which is kind of like how lightning is created. When cold air and warm air meets, the molecules in the air jitter out of their normal realm of harmonics, and energy is created. At this point, once the energy gets to a certain point, it has to discharge, and that's how you get lightning, which is basically the same thing that's happening here. What this is doing is this circuit here is turning the primary coil on and off approximately 700,000 times a second, 700 kilohertz. Okay? And that's creating a magnetic pulses that's causing the molecules in the air to jitter. Now, we're exciting the molecules. Now we have to slay them or capture them. And that's what the coil is. The coil is to slay those molecules, the energy that they're creating. That's why it's called a slayer exciter. Okay. Now, here we're creating right around 90,000 volts, which should kill me. Okay, don't get me wrong. This is nothing to play with. Okay, but I've worked with electronics enough. Plus, there's enough people that have done this, and thanks to my friend Gary Luger, who gave me some help with this. You've made this so it doesn't hurt. I should be getting electrocuted right now if this was. The reason why I'm not is this is high frequency. High frequency runs across the surface. Low frequency penetrates. The voltage coming out of your AC wall socket is 60 times a second. This is 700,000 times. That's the main difference. Now, because the difference, it only runs across the surface of my skin. Otherwise, it would penetrate my heart and stop my heart instantly. Actually, in a nanosecond. So please don't try it at home. It is dangerous. It's nothing that you really want to play with until you totally understand. Electricity is something that you have to respect. You can't take it for granted. Okay? So, anyhow, let's get back to a little Tesla history. Did I miss something here? Oh, okay. Yeah, I am missing something. Tesla said there was more energy in the air around us than we could ever use in our entire existence. And he's right. And I'll prove it to you. Okay? I'll prove it to you right now. This right here is a petawatt laser. It's the largest laser that's functioning in the world right now today. Here at the Lawrence Livermore National Laboratory, the scientists there say that they can focus this laser. This is just one little part of it. This thing actually covers 3 football fields. Okay? That's how big it is. Now, they say that they can focus this thing on one molecule of hydrogen. A molecule is so small we can't see it, right? They can focus this thing on one molecule of hydrogen and peltering it with all that photonic energy. It creates a nuclear fusion, which they say will create enough energy to power California for a day. So in other words, one little drop of water can power the United States for weeks, months, possibly even years. That's a lot. You know how many molecules are in the air in this room right now? More than any of us can even count. So, I mean, just the air in this room alone power the world for years. So that's if they're 100% correct. Now, This right here, when this is on, it's creating the magnetic pulse, which is creating energy out further. As you see all that, right? See that? Maybe trying to light up over here. So, what we needed to do in order to create this much power is we needed to capture some of that energy that's out here. That's what these other two coils are for. This coil is actually pumping power back into the negative side of this. And this coil is pumping power back into the primary, which is increasing its magnetic flux density, or also known as its Tesla. Okay? Which, the scale of Tesla is so accurate, every MRI in the world is calibrated to the scale of Tesla. Which, personally, I think that's amazing alone. I mean, the man came up with that scale, and that's what he's got. He's got his own scale of magnetic flux density. So, by increasing the magnetic flux density is one of the reasons why you can actually see it and hear it. You know, that, I'll show you a little more about it. That's mini force lightning from Star Wars. You know? So, and this light bulb was trying to light up back here too. So, anyhow, back to the Tesla history here. Now, Tesla came to the United States in 1884 to work for Thomas Edison Electric Company. But Edison had very strict and greedy ways about it. He was very jealous of Tesla because how smart Tesla was. He told Tesla that anything that he invented, created, or discovered, whether it was in his own home or in the lab at work, was the property of Edison Electric Company. Well, that didn't go over too well with Tesla. Tesla didn't really care for that too much. But being the scientist he was, and he was in it for science, he overlooked that. But later, Tesla was telling Edison, you need to get away from DC voltage. You need to go to AC current. But he didn't want to listen. And that's really the straw that broke the camel's back. Throughout the almost year that he did work for Edison, Edison got many of his discoveries and inventions, which it's taken until just the last few years that historians are actually making things right and giving Tesla the credit that he deserves. Now, Tesla went to work for George Westinghouse in 1885, in 1885. And he and Tesla designed and built. All together, they both. Westinghouse funded and had all the people to build this, whereas Tesla designed the transformers, the generators that were inside of it, and how it was going to work. That was Tesla's design. So Tesla designed all this. And together they made the world's first hydroelectric power plant, which is at Niagara Falls, and it was completed and fully functional by 1895. So, now, a little more about Tesla. Tesla felt that because all of the molecules in the air, you're getting electricity from the molecules in the air, that it should be free. Okay? Now, which I understand what he's saying. So, remembering that he already did the one experiment in front of the president of Edison Electric Company, and they didn't want nothing to do with it if they weren't going to make money off of it, right? He kept that in mind. So he rallied a few of his investors together, and he told them he wanted to build the world's first transmitter, and he wanted to transmit to the world, which, you know, they were all for that because they could see dollar signs. Tesla didn't tell him that it was to transmit free electric to the world. He was trying to make his dream come true. Well, 1 week before this was totally built, he broke down and told his investors what it was really for. They got really mad at him. They pulled their funding. They sued him, and they tore it down. It was reduced to a pile of rubble by 1917. Tesla said that was the saddest day of his life. Now, Tesla being a great visionary as well as humanitarian, he wrote a paper to the United States government and to the scientific community that protective shield around the Earth. It was a paper entitled Tesla and the Heart. In this paper, he said the protective shield around the Earth was going to open up over the poles, and the black mass of the universe was going to pollute our planet. He told us about global warming back in the 1920s. Nobody else had an inkling of what was going to happen at that point, but Tesla could see it. He told them how to fix it, and that's what the heart is. The heart was featured on Jesse Ventura's conspiracy theory. It was supposed to be mind control. And I hope you're watching this, Jesse, but that's fake. That was all for your show. It's nothing to do with mind control. It was about fixing our ionosphere, about fixing the ozone layer. That's what it was mainly for. Now here you see how these are shooting straight up from the antenna array. And this is all green. If this was a true aurora borealis, it'd be all kinds of different colors. But here they're only energizing the xenon gases in the air. That's why it's green. See how it's shooting up? Well, that's because it's all coming from the antenna array. So I don't know what frequency it is, but they're on a certain frequency to where it's just affecting the single molecules in the air. This is to give you an idea how big it is. This is up in Alaska. Recently, the United States government took down the HAARP's website, which kind of bothers me because I used to like to go there and check out what they had up there, because they used to post a bunch of their findings. It's kind of neat, especially seeing some of their maps from outer space and seeing what's happening. But this right here is its antenna array. That antenna array covers 35 acres. That facility back there, that's about a 10-acre facility, I believe it is. But now, Tesla told them in 1920 about it. Well, they didn't start building it until 1990 because, remember about the tower? They thought, oh, he's just trying to trick us again. But later, after other scientists basically told them the same thing, they decided, well, maybe we need to listen to them and do it. So they built it. That's only one. The United States has 2 others. I can't find any information on them. I do know that we do have 2 more of them. But this facility here can crank out 36,000 kilowatts. No, 3,600 kilowatts. So if you were to really look at that, that would be 3,0600,000, which is really 3,600,000 watts of power. It's a lot of power here. A lot more than any radio station we listen to, right? The HAARP also covers frequencies from high frequency, which is megahertz, well past the ultra high frequencies and into super high frequency, which is gigahertz, which is extremely fast. Now, Tesla was also featured on the cover of Time magazine, the July 20th edition, 1931. And in this featured article, Tesla stated that he was going to explain through a series of mathematic equations things Einstein couldn't even explain. That's how smart that man was. He was extremely smart. Tesla's been credited for radio and television, for AC electricity, the Tesla coil, fluorescent and neon lighting, radio control devices, robotics, x-rays, MRIs, radars, microwaves, concentrated directional energy. Yeah, Tesla had a death threat. Remember how the Japanese bombed Pearl Harbor in 1941? Well, in 1939 and early 1940, he was petitioning the United States government, telling them, if we put this kind of a facility centrally located or located in strategic places around the United States, that it would create an impenetrable force field that our enemies could never breach. Now, he said he could knock out a plane and detonate all the weaponry from 200 miles away. And that was his death ray. Now Tesla, if he was going to school with you all today, that man right there, you guys would all look at him like he was a nerd. But you gotta remember, that nerd right there was pioneering the technology for your smartphones. If it wasn't for him, in 1901, he was really, truly working on smartphone technology. It took us this long to get it. Wait a minute now. The world had to catch up to him. That's one smart man. If it wasn't for him, we'd still be using DC current. A place the size of St. Anne would require 2 power plants to power St. Anne. Because DC current is just not that feasible. So he got us to AC current. He designed the motors, and everything. He also pioneered the technology for all kinds of things that we use today. Our microwave ovens, internet. You gotta remember. How many of you guys play games online, like Combat Arms? Anybody? You do? What about Roblox? Any of you guys use the internet at home? Everybody does, right? Well, if it wasn't for that nerd, you wouldn't have it. If it wasn't for that nerd, nobody would be making the programs that you guys play the games. You guys play PS2, right? Or PSPs? Or,
yeah, PSPs
or,
and PS2s.
Right, exactly. Or Xboxes. It's his technology that you guys are using. It's his technology. So, you guys gotta remember, the nerd just might be the next Tesla. Anyhow, let's. Anybody have any questions?